So remember, a compound inequality is two or more inequalities that has what words between them? And or are. Now, when you solve the and inequality, what are you looking for? The intersection. When you solve the or inequality, you're looking at the union. So everything that's shaded. Now, remember the process, though. The process is you've got to solve for x for each individual inequality. Then you graph each one, and then that's where you look for the intersection. Remember that? Okay, so in the first one, how do you get x by itself? All right, divide by 4. And so 4 divided by 4 is 1. 1 times x is x. Is greater than or equal to, and then what's 0 divided by 4? 0. Over here, what do I do first? Subtract 4. And then combine like terms. So I'm using the addition property of inequality. These are inequalities. So it's the same as the addition property of addition for equations. This is inequality. All right, so we get 2x is less than or equal to, and then what's 2 and a negative 4? All right, what's the next step? Divide by 2. And so you get x is less than or equal to negative 1. All right, now remember what this right here means. So x greater than or equal to 0 means what? What does that mean? What does this represent? Say it again? Okay, that's what it says. So x is greater than or equal to 0, but what does that represent? What have I just found? What do you mean by answer? The solution. The solution of which inequality? The first one, this one right here. So the solution to this inequality is this. So any real number greater than or equal to 0 is going to make this inequality, the original inequality, a true statement. What does this right here imply? All right, so any number less than or equal to negative 1 will be a solution to this inequality, right? Okay. All right. Now, I'm trying to find the solution to this compound inequality, though. So both of those. And notice there's the word "and" between them. So you're looking for the solutions that make this true and at the same time makes this true. So whatever your solution to this compound inequality is, it's got to satisfy both of those inequalities. So for example, is negative 1/2 a solution? So the question is negative 1/2 a solution? Well, okay, why not? Okay, it's not less than negative 1, and also what? It's not greater than 0. Okay. All right, so the answer is no. What about is 2 a solution? Well, 2 is greater than or equal to 0, but it's not less than or equal to negative 1. So it's got to satisfy both of those. So the answer is no there. What would be a solution, do you think? Just give me one real number. 1? All right, so you see how you're kind of struggling with that? All right. So what you need to do is this. You need to graph each one individually, right? Graph each one individually. All right. So here's your work. This is the work you're going to show. So you're going to graph, first of all, you're going to graph x is greater than or equal to 0. All right. So remember when we did this, we put 0 on the number line. And then on 0, do I use open or close circle? Close, because there's an equal sign. So 0 is a solution to this inequality. Remember, I'm just graphing the solution to this one. Which way do I go? To the right. Okay. Now let's graph the next one. The next one was x is less than or equal to negative 1. So again, align your number line. So make sure they're aligned. So there's 0 again. Now, which side do I put negative 1? On the left. All right, open or close circle. Closed, because there's an equal sign, so negative 1 is a solution to this. So it's going to be closed. Which way do I go? To the left. Okay. Now, See, once you do the work, you should now be able to tell me the answer. What's the solution to this compound inequality? There is none. So when I asked you what would be a real number that would be a solution, you were struggling with this because you couldn't visually see it. All right, so now you can visually see it because remember, the solution to a compound inequality would be where the two graphs overlap. Does the shaded part overlap anywhere? No. All right. So on your worksheet, if you recall the worksheet, there's a graph there, and I think it may be numbered. So it may be like 0, 1, and so on. What would you graph? Huh? Say it again? Why would you graph negative? You can't graph anything. There's no solution. So you leave the graph blank, right? All right. Now, here's what I want you to say though. Say right near it, say no solution. Because remember, when you shade in your final graph, you're shading in the solutions to this compound inequality where there aren't any. So there's no solution. Now, the interval notation, what would you put in the blank? Say it again? Oh, okay. So that you're talking about the empty set, right? Yeah. So you could have said here's no solution, or you could have said the empty set. Remember that the word empty set? I think my math lab uses the empty set symbol. Same thing here. You could say no solution, or just say the empty set. Okay? All right. Now, let's look at this. All right, so let's say this was number 2. All right, number 2, let's suppose you had x plus 5 is less than 9, and 3x minus 1 is less than 2. All right, what are you going to do? All right, so you're going to solve each one individually. So x is less than 4. So I found the solutions to this first inequality. So any number less than 4 is going to satisfy this first one. Over here, what's the next step? So I get 3x is less than 3. Next step, divide by 3. So x is less than, not 3, 1. X is less than 1. Okay? All right. So remember, the x is less than 1 means that any number less than 1 is a solution to the second inequality. Now I've got to find the solution to the compound inequality. So what solutions make both true at the same time? So here's your work. Now this is part of your work as well, but here's the work to get to the graph. You're going to graph the first one. So x is less than 4. So let's always put 0 on here. So 0's here. Where's 4? On the right. Okay. What do I put on 4? Open circle? Yes. Okay. So I put an open circle on 4. Going which way? To the left. All right, then the next one is x is less than 1. All right, again, align everything. So here's 0 again. Now where do I put the 1? Can I put the 1 here? No. Make sure it's aligned with the one we just did. So let's say 1's here. Open or closed? Open. Going which way? Left. All right, so then your answer. All right, so remember, this is an and statement, so you're looking for the solutions that they have in common. So what do they have in common? To what? 2, 1. So anything from negative infinity to 1, and that's it. So in your graph answer, you're going to put 1 here, open or closed? Open, going which way? To the left. Now what's the interval notation? Now some of you are still having issues with the interval notation. You read a graph from left to right. Parentheses, negative infinity, comma, 1, parentheses. Okay. All right. So that was the end. So if you look at the R, all right. So let's say the R we had this. All right, we had 3x all right, 3x minus 2 is greater than or equal to 10, or x minus 6 is less than or equal to negative 4. All right, so again, you solve each one individually, but this time remember it's an OR statement. So R means that the solution to this compound inequality has to satisfy one of these. It doesn't have to satisfy both. It just has to satisfy one of them. All right, so again, you do the same thing. You solve each one. So let's deal with the first one. What are you going to do next? Add 2. All right, so 3x is greater than or equal to 12. Next up. So my solution to this first inequality is going to be any real number that's bigger than or equal to 4. Over here, add 6. So the solutions to this one's going to be any real number that's less than or equal to 2. Not 10, negative 4 plus 6. So that's 2. All right. Okay, so then we graph each one individually. So we're going to graph the first one. So here's 0, here's 4, open or closed, going which way? To the right. Okay, the next one, x is less than or equal to 2. Here's 0. So I'm going to put 2 between 0 and 4, right? Open or closed? Closed. Going which way? To the left. All right, now if this was an AND statement, though, what would the solution be if this was an AND statement? There wouldn't be any solution. There would be no solution. All right, but it's an OR statement. So anything shaded is a solution. So look at what's shaded. So from here, all that's shaded, right? And also this. So anything shaded is a solution. So on when you do your answer for the graph, what are you going to shade? Negative infinity. Okay, so let's say this is 2 right here. Open or closed? Closed. And then where else? From 4, open or closed? Going which way? To the right. So this graph, the solutions are two parts of the number line, from negative infinity to 2, and then from 4 to infinity. Now, what would the interval notation be? Now, my math lab, remember my math lab, they're going to tell you to separate them using a comma. On your worksheet, though, in your test, use the union symbol. So my math lab, tell me what you would write.
Negative infinity, comma 2,
Bracket? No bracket, closed circle. Comma. Okay, on my math lab, you're going to use a comma. On the worksheet or textbook, you're going to use the union symbol. So it'll be negative infinity to 2 bracket union. All right, now what will be the next interval?
4, infinity.
Okay, parentheses, and then bracket 4, infinity, parentheses. Okay? All right, and then there was one other special case that we talked about, and that was this one, or something to look like this. So let's suppose you had x minus 7 is less than or equal to negative 1, or 2x minus 6 is greater than or equal to 2. So again, you solve each one individually. So what would you do for the first one? Okay. So the solutions to this first inequality will be any real number that is less than or equal to positive 6. All right, over here, add 6 to both sides, right? So 2x is going to be greater than or equal to, you don't want to, all right, 8. 2 plus 6 is 8. What's the next step? Divide by 2. So the solutions to this second inequality will be any real number that's greater than or equal to 4. All right, so we graph each one individually. So let's do the first one. X is less than or equal to 6. Looks like this. So here's 0, here's 6. Open or close circle? Close, going which way? To the left. Okay. Then here, x is greater than or equal to 4. Align your number line. So here's 0 again. Where's 4 going to be located? Okay, somewhere around here. Open or closed? Close, going which way? To the right. Okay. Now remember, this is an OR statement, so it's a union of those two graphs. So anything shaded is a solution. So look at what's being shaded. So in terms of your answer, on this number line, what would you shade? Everything. So everything is being shaded. All right, everything's being shaded. So every number, every real number is a solution. So what you would do in this on your answer is you just do something like this with the arrows. All right, so that would imply that it's this whole number line. Now, what would the interval notation be? Negative infinity to positive infinity. So parentheses, negative infinity, comma, infinity, parentheses. Okay, so that's what we talked about last class period. Then we started talking about compound inequalities. So remember on one of your worksheets in a previous lesson, you were asked to graph this compound inequality that looked like this. X is less than or equal to 6 is less than or equal to, let's do less than negative 1. So negative 1 is less than x is less than 6, less than or equal to 6. So this is a compound inequality because you have two inequality symbols there. And notice the direction of those inequalities. They all point in the same direction. Less than, equal to. All right. So if this was greater than, this would be greater than as well. Okay. Now when you graph this on the number line, you're graphing all the solutions, all the real numbers that are between what two numbers? Negative 1 and 6. And on negative 1, what'd you put? Open circle. On 6, what'd you put? Close, because the equal sign. And then you just shade between them. Notice that this one did not have any arrows attached to it. So then, now notice that in the previous lesson, what was in the middle? What? No, right here. Well, it was just x, right? It was just x. So when x is in the middle, you can easily graph the solution. So then we started talking about something that looked like this. So this is number 26. That's on page 1209. All right. So you have negative 2 is less than or equal to x plus 3 is less than or equal to 0. So you want to find the solutions to this compound inequality. Now you want to make it look like the one that you've done before where you got to get x in the middle. So if I were to cover this part up, that would be something that you could easily do. If all you had was this, what would you do to both sides of this inequality? Subtract 3. But you don't have just this. You have this compound inequality. So there's actually 3 parts. There's the left side, the middle part, and the right side. So when you subtracted 3 from here, then you would also have to do what to this? Subtract 3 as well. So you're going to subtract 3 from all 3 parts. Left side, middle, and then the right side. and then you combine like terms. Negative 2 and a negative 3 is a negative 5 is less than or equal to, and then what's left here? X is less than or equal to negative 3. So I found the solution to this original problem. So any real number between negative 5 and negative 3 is a solution to the original problem. And you can check what will be a nice number to use between negative 5 and negative 3. Negative 4. All right, so let's check to see if negative 4 actually works. So you go back to the original. And so you're asking yourself, is negative 2 less than or equal to, and remember x is what here? What am I letting x be? Negative 4 plus 3, and is that less than or equal to 0? Well, just do this. What's negative 4 plus 3? Okay, so here's a question. Is negative 2 less than or equal to negative 1? Yes. Is negative 1 less than or equal to 0? Yes. So negative 4 is the solution. All right, so you found the solutions to this original problem. So now remember, there's, how many solutions are there? You think there's just 2? Say it again? An infinite number. Remember, any real number is a solution. So don't think that integers are the only real numbers. You have decimals as well, right? You have fractions. So on the number line, you're going to say from negative 5 to negative 3. And on negative 5, to use open or closed circle. Closed. On negative 3, closed, and you shade in every number between them. So there's an infinite number of numbers here. You have all these decimals, negative 3.9998765, and so on. So you have all these infinite decimals that's involved here. So there's an infinite number of solutions. Okay. So any decimal is a solution that's between here. Any integer is a solution. Any fraction that's between these two are solutions. Any irrational numbers between those two are solutions, and so on. All right. Then we started looking at something like this. This is number 30. So number 30, you have negative 2 is less than 1/2 x minus 5 is less than 1. All right. Now, again, if I were to cover this part right here from a previous lesson, what would you have done to this part? Add 5, okay. So we're going to add 5 here, here, and also here, right? Okay, what's negative 2 plus 5? Okay, so 3 is going to be less than, and then what's going to be in the middle? 1/2 x, and that's less than 6. All right, so remember, I got to get x in the middle, though. So I have a 1/2 x here. So what can I do to all three parts to get rid of that coefficient? Okay, multiply by the reciprocal. What's the reciprocal of 1/2? 2. Or now remember we talked about this before. So we could multiply both sides by the reciprocal of the coefficient, or we can actually divide both sides by what? 1/2. So it doesn't matter which one you use, but whatever you use, you got to do to all parts. So you would have to say divide by 1/2, divide by 1/2, divide by 1/2, like that. Or you would have to say, again, what's reciprocal of 1/2? 2 of 1, or just what? 2. So times 2, times 2, times 2. So either one's will be fine. This one will probably be easier for you in this case, because what's 2 times 3? 6. It's less than, right, because 2 times 1/2 is what number? 1. 1 times x is less than 12. So here, this is a little bit more involved, because when you divide by a fraction, it's a little bit more involved. You got to remember something from a previous course. So 6, right here. So 6 divided by 1/2, remember, that's 6 times the reciprocal of the fraction down here. What's the reciprocal of 1/2? 2, which is what? 12. That's what we got here. Over here, 1/2 divided by 1/2 is 1. 1 times x is x, so that's how we got this right here. Here, that's 3 divided by half. Remember, you change a division multiplication, so you multiply by the reciprocal. So it's 3 times the reciprocal of 1/2. And what's the reciprocal of 1/2? 2, which is just what? 6. And that's how we got this. So see, this is a little bit more involved. So multiplying by the reciprocal may be easier for some of you than dividing by the coefficient. Okay? All right. So again, you get the same thing. It doesn't matter which one you use. Okay, so then your answer, what are you going to put? What are you going to shade? Between what? Between 6 and 12. On 6, open. 12, you shade everything between them, right? How many solutions are there between 6 and 12? An infinite number. All right. What would the interval notation be? Okay. All right. Okay, let's look at 32. 32. Now, the way I would do 32 is this way. So look at what 32 looks like. You have -4 is less than or equal to, and then you have -2x plus 5 divided by 3 is less than or equal to 1. All right, so you have this compound inequality. And again, if I were to cover this part, and if this was an equation on the test you just took, if this was an equation, how would you solve for x? What would be the first thing you would do? If this was an equation, what would be the first thing you would do? There's nothing to combine. Get rid of the fraction. So how would you get rid of that fraction? Multiply by the LCD. What's the LCD here? 3. Okay. So remember on that test you just took, didn't you have any fractions on that one? All right. Okay. So you multiply by the LCD. So that's what you want to do here. So the denominator is 3. So 3, and then this is a 1, and this is a 1 as well, the denominator. So the LCD is 3. So what you're going to do is you're going to multiply all parts by 3. So I'm going to go ahead and rewrite this over. And notice how easy this will become when you do that. That's -2x plus 5. All right, so you're going to say times 3 times 3 times 3, just like this. You multiply all parts by what? 3. And the whole reason you're doing that is to clear this denominator that's a 3 right here. So what's 3 times a -4? It's less than equal to. Now these 3's divide out. See what I just did? And then 1 times -2x plus 5 is just what? -2x plus 5. And that's less than equal to what? 3. And now you can easily do the rest. So you don't have that fraction to make it difficult for you. So now if I cover this part again, what would be the next thing you would do? Subtract 5. Okay, but you can subtract 5 from all 3 parts, just like this. So what's -12 and a -5? It's less than equal to -2x. It's less than equal to -2. All right. Now what's the next step? All right, I'm dividing by -2. So I'm going to go ahead and rewrite this over. I'm dividing by -2. Now remember, what else do I need to do? Reverse the equality symbol. So I'm going to circle these to remind me to do that. All right. So a -17 divided by -2 is not a whole number. So you're going to leave it as a fraction. But remember, the negative divided by negative is a positive. So that 17/2 is what? Greater than or equal to, and then -2 divided by -2 is 1. 1 times x is x. And then this also becomes what? Greater than or equal to, and then what? 1. Okay? All right. Now, you can leave it like that. It's no big deal. But But remember, when we graph though, we graph from small to large. Okay? So if I were to put this on the number line, if I were to graph my solution on the number line, what would I put first? 1. You'd put 1 first because 1 is smaller than what? 17/2. So if you need to, just rewrite it backwards. So you're going to say 1 is what? Less than, good. You're going to write everything backwards. 1 is less than or equal to what? X is what? Less than or equal to 17/2. Okay, this and this are the same thing. So we put 1 first, and then 17/2 next. And then on 1, what do I put? Nope. Closed. The equal sign. On 17/2, closed, and then shade everything between them, right? Now, if it was a number line that was numbered, in other words, if it looked like this, I just want to remind you what to do. So if this is, let's say, 1, and this is, let's say, 8, 9, 7. Okay, the 1's easy. You're going to put a closed circle here. But where will you put 17/2? How do you know where 17/2 is located? Yeah, just use your calculator. What's 17 divided by 2 in your calculator? 8.5, right? So 17/2 is in the middle of 8 and 9. So here's 17/2, and then open a closed circle. Close, and I shade in everything between them. Okay? What would the interval notation be? Or 17/2 doesn't matter. 8.5, 17/2 doesn't matter. All right, but do not do this. Okay, so if you leave it like this, don't say this. Don't say bracket 17/2 comma 1. That's incorrect. Because when you write something in interval notation, you always go from where? Small to large. Okay, here you go from small to large. I mean, large to small. All right, so that's incorrect. So this should be the correct answer, correct interval. All right, this one's incorrect. All right, let's look at this one. Okay, suppose we had, this will be number 60. All right, number 60. All right, suppose you had -5 is less than 2 times x plus 4 is less than 8. All right, so what are you going to do? Okay, distribute first. So -5 is less than 2x plus 8 is less than 8. Next step. Subtract what? 8 from all parts. What's -5 and -8? Okay, it's less than 2x. It's less than, nope, 0. 8 to -8. Then finally, the next step. Divide by 2, just like this. And then so you get -13/2, right? It's less than what? X is less than 0. Okay. So on the number line, let's say this is 0 here. Let's say this is -6, -7, -5. Okay, where do I put -13/2? First of all, figure out what -13/2 is as a decimal. Negative what? -6.5. All right, so that's between -6 and -7. So let's say that's here. All right, open a closed circle. Oh, not closed. Open because there's no equal sign. And then 0 is going to be open as well. And then I shade in everything between them. All right? What? What's wrong? All right. What's the interval notation? Yep. All right. Okay, let's look at 68. All right, 68, we have negative 1/2 is less than or equal to 3x minus 1 divided by 10 is less than 1/2. Okay, make it easy on yourself. So you have fractions. You want to clear those fractions. So what are you going to do? LCD. What's the LCD? 10. The smallest number that 2, 10, and 2 go into is 10. So the LCD is 10. So that's where you're going to multiply all parts by what? 10. So the LCD is 10. So it's going to look like this. I'm going to go ahead and rewrite this over. All right. So I just wrote the problem over. So I'm going to say times 10 times 10 times 10, just like that. All right, now let's go ahead and multiply. What is 10 times a negative 1/2? Negative 5. That's equal to. Now these 10s divide out. That's the whole purpose, remember, to get 1s in their places. What is 1 times 3x minus 1? All right, it's less than. What's 10 times 1/2? Positive 5. All right, so now I don't have any fractions to deal with. Okay, what's the next step? Add 1 to all parts. What's negative 5 plus 1? Okay, so less than equal to 3x is less than 6. Okay, next step. Divide all parts by 3. Okay, so I get negative 4/3 is less than or equal to x is less than 2. All right, so on the number line, so I found the solution. So the solution to the original problem, the solution to this right here, the numbers that make this a true statement is going to be any number that's between what? Negative 4/3 and 2. No other number is going to work. Only these real numbers. So you have negative 4/3. Oops, let me do this. Let me write this as, let's say this is negative 1, this is 0, this is negative 2, 1, 2. All right, where's negative 4/3 located? Between what two numbers? Between negative 1 and 2, but closer, if you use your calculator, negative 4/3 is negative 1.333, and so on. So it's closer to negative 1 or negative 2? Negative 1. So let's say it's about here. It says negative 4/3. Open or close circle? Closed. For 2, open or closed? Open. And I shade in everything between them. All right, what's the interval notation? Okay. All right. All right, let's do one more with this. So we can do number 70. Number 70. Okay, so number 70, you have negative 1/4 is less than 6 minus x divided by 12 is less than negative 1/6. Right, so negative 1/4 is less than 6 minus 6 divided by 12. It's less than negative 1/6. All right, so clear your fractions. What's the LCD? 12. So LCD is 12. So I'm going to go ahead and rewrite this over. So here's negative 1/4. It's less than 6 minus 6 divided by 12. It's less than negative 1/6. So that's where you're going to multiply all parts by 12, just like this. All parts by 12. All right, now what is 12 times the negative 1/4? Okay, negative 3, right? A positive times a negative is a negative. 4 into 12, remember what you're doing is this. You're saying 12 times negative 1/4. 4 into 4 is 1. 4 into 12 is what? 3. And so what's 3 times a negative 1? Negative 3. It's less than, and these 12s divide out. 1 times 6 minus x is 6 minus x. All right, what's 12 times 1 times a negative 1/6? negative 2, negative 2. 6 into 6 is 1, 6 into 12 is 2, and you get 2 times negative 1 is negative 2. All right, so that's where I'm at. Okay, now what's the next thing you would do? Subtract 6 from all parts. Okay, just like this. Okay, what's that negative 3 and a negative 6? It's less than. What's left in the middle? Not x, negative x. It's less than? Negative 8. All right, remember we're trying to get x, right? Not negative x. So what do I need to divide all parts by? Negative 1. Because remember, negative x is the same thing as saying negative 1x. So I'm going to divide all parts by negative 1. But remember, I'm dividing by a negative number. So I've got to reverse this, right? So what's a negative 9 divided by a negative 1? So 9 is what? Greater than x, because negative 1 divided by negative 1 is 1, is greater than 8. All right. Now, remember though, when you graph this, so this says that all the solutions are between 9 and 8, right? But we got to say it correctly. We go from small to large. So in other words, it's actually between what? 8 and 9. So if you want to rewrite it, you would say 8. Now, don't say 8 is greater than. You got to say 8 is what? Less than. X is less than 9. So you put 8 first. You put 9 next. We go from small to large. 8, what do I use? 9. And shade in between. What's the interval? Parentheses. Okay. All right. So that should take care of the worksheet part. So